Hi, I'm Larry Puckett, the DCC guy. If you remember a few weeks ago, I requested help in trying to replace this broken drive gear on a steam locomotive that I have in my collection. Unfortunately, the gear is cracked and it doesn't mesh properly with the idler gear, and as a result, the locomotive skips and jumps and wobbles all over the track. And also, unfortunately, the company that made the locomotive no longer produces this replacement gear. And unfortunately, they tell me they've lost the original mold for this gear. And in that particular video, I ask for help in replacing this gear. So let's go ahead and take a look at the process I went through in order to create a 3D model of the gear that could be printed out, and then passed it on to some viewers who were kind enough to help me out. So let's go ahead and take a look at that. Well, let's go ahead and get started with a couple of announcements. Now, I do want to remind my UK viewers that I will be attending the Warley National Train Show November 26th and 27th in Birmingham at I think it's the National Exhibition Center. So if you're going to be attending Warley, look me up. I'll be either at the DCC Concepts stand, which is huge. I think it's something on the order of 56 feet long, so you can't miss it, and I should be there part of the time. I'll also be wandering the aisles looking for great deals and also looking for new products. So if you do see me walking the aisles there at Warley, feel free to come on up and introduce yourself, and we'll talk for a few minutes and get to know one another. Okay, now the other thing I want to point out is in my previous video on circuit breakers and the like, and how you can protect your layout using TVS diodes. Now, in that video, I mentioned that the PSX and PSXX circuit breaker devices do have TVS diodes on them, so you're partially protected there. I also was taking a look at this. This is an NCE EB1 circuit breaker, and if you look right here on the back of it, there's a little rectangular device across the terminals for the output. That is a TVS diode as well. So they have added TVS diodes. The guys at DCC Specialties have TVS diodes on their PSX and PSXX. So you're partially protected if you're using either of these devices or any of these devices. And there might be others out there. And I've placed an order with DigiKey for some of these myself, and I'll be showing you in a future video how to install them on existing decoders. Let's go ahead and take a look at these 3D replacement gears that viewers produced for me. And I want to thank the guys, Tim Delahaye in the UK, who did this black set, Jeff Paul, who did, I believe, the white set, and Todd Russell, who did the gray set. So these guys were nice enough to take the file that I sent them. It was produced in a program called Fusion 360 that is used to create 3D models and then generate the files that are used to print these out. I'm sure that, all of these will hold up to some degree. It's just how long they will. We'll find out. One thing I did, and I'll remind you, this one right here up front is the original, and this is a set of black ones. And I've got these in a range of different sizes because in my printer file, I created a range of sizes so that I would have something to choose from and to test. So these range anywhere from around 11.5 millimeters to about 11.7 millimeters in diameter, which is about what this guy was. And it's got a 3 millimeter diameter opening for the axle to go in. So we're going to see how these are going to hold up as I first slide them on to the axle, because the axle is right at 3 millimeters, and then it has a set of splines cut into it, or molded or whatever, stamped into it, that grips the inside of the plastic hole and keeps it from spinning, so it allows it to drive the locomotive. So hopefully these will not split out when they are slid onto that axle and then on top of those splines. But we never can tell, and I don't know as yet because I haven't pre-tested this. You know, I'm going to be doing this as it comes, and if all of them break, that'll be the end of that project, and I'll have to try something else. So that's what our result is going to be in this video. It either works or it doesn't work, and we move on. What I got to do now is I'm going to start with these black ones here because Tim Delahaye told me that these are a very strong material. So I'm going to go ahead and do some test fits with this guy here and make sure that they find the ones that mesh the best with it, and then I'll slide it onto the axle. So first thing, I've got to get that locomotive out, and we'll put it in a cradle and pull out the driver set that has the gear on it. So let's go ahead and do that. Now, unfortunately, I did not discover until after I had completed all the work on this project that the segment that I shot showing you how to remove the driver, pull the wheel, and replace the gear on the axle, that video footage was corrupted in the process somewhere. So I just don't have it. It's unavailable. So what I'm going to have to do is reconstruct that. Now, also, since I've already completed this and am happy with what I've got here, I can't completely undo it. Because if I did, I would mess something up. So I'm just going to have to walk you through the process, and hopefully I won't disturb anything as I go along. So the first thing you have to do is remove this section here called the base keeper plate, and it entails taking these 3 screws out here on the bottom. Okay, so that's ready to come out. So that just lifts off. And then at that point, you have access to the little contacts that rub against the back of the wheels and provide power pickup. Now that gives us access to this piece of plastic here that holds the axles in place. Now I have to first remove this one, the trailing truck, because it is in the way of removing that piece of plastic. This piece of plastic is held in place right here at the rear with a couple of clips. So I'm just going to slide an X-Acto knife blade under here and just pop that loose. You don't want to cut it, you just want to use this as sort of a wedge to pop it up. There we go. And that will come loose, and then you can lift this. Now you have to be careful because you see this little brass rivet? There's a wire attached to it that feeds up through the chassis. So you just have to lift this enough to get clearance. Okay. Now, I don't want to disturb these guys. As you'll see in the video, there's a reason I don't want to take these out. Okay, so at this point, we have access to the main driver. One thing you need to do is remove these screws that hold the drive rods and the coupling rods in place. And that's best done on the side, and I can't do that because this will fall out. So at this point, you know, really you could probably do this before you even get to the point where you're trying to access the drive axle itself. Now if you look in here, once you take those 2 screws out on either side, then this would just lift right out and you can access it. At that point, this particular wheel here needs to come off because you can see this is the plastic drive gear right here, and so this axle needs to come off so this can slide out because there is a bearing on this side. To do this, I typically would just take a pair of needle nose pliers, put it on the inside of that wheel, on the back side of it, and just push out. And the reason that works with these is the wheel here is primarily a plastic insert with the metal treads on it. Okay, so that will slide right off of the end of that axle if you just give it a little bit of pressure. But be careful because there are splines on the end of the axle that engage with indents in the plastic casting and keep it from spinning when the wheel turns. Okay, so once you get that off, then you can get your pliers out again and press against this gear and push it off of the splines. So it's set into, it is pushed onto the axle, and then there's some splines that are pressed into the axle itself, and that's what keeps this gear from just spinning idly. So get that off, and then you can take your replacement gear, like this one here, and slide it on over the axle end and push it on to the splines. And that allows it to be stabilized on the axle. And then you just press the wheel back in place again. One thing to remember, with steam locomotives, the wheels are actually put on in what's called quartering. And what that means is that the screws that hold the drive rods in place are offset by a quarter of a turn. So you have to be very careful putting this back together again. You want them to face in the proper direction, and you want them to be offset by a quarter of a turn. That process really isn't as difficult as it sounds, because you have the two axles or the two drivers on either side to look at for the position of these pins on the opposite sides, so you can get them properly quartered. And then when you push it back on, when you push the wheel back onto the end of the axle, the splines on the end will register with the indents on the inside of the opening on the plastic wheel. So you can just slide that back on and then compare the two sides, and you can visually tell whether these two are offset by a quarter of a turn. So make sure you get that set up, because otherwise it will give you very rough rides, let me tell you. So you have to get that properly quartered. It might be a little tight the first time, but after that it should go on fairly easy. Now, if you find that it is very loose, what you can do is put a little PVA glue on there. And that way it will slide on, and then when the glue sets up, it'll hold it pretty well. Then if you ever need to remove it, of course, you can just take some water and put on there, loosen it up, and pop it off. But do not use anything like super glue or any glue that's going to really hold tight, because in the future, if you ever need to pull those wheels again, you might not be able to get them off. Now, I'll tell you one other thing. Hornby, who made this locomotive, sells replacement wheel sets. But one of the problems with that is I have no idea if they will properly work with this locomotive, because this is one of the older versions of the locomotive, and I suspect that the wheel sets they're selling now are not 100% compatible. So, it's a roll of the dice as whether or not they will work. I know for a fact, though, that the gear that they are supplying on the new wheel sets is not the right size, which is why I'm going about this process of 3D printing a replacement gear. Before we go on, I want to ask you to take a moment to subscribe to the channel. It's simple, easy, and free. All you have to do is hit that little red subscribe button, and when the little bell comes up, click on it and click all. Okay, so at that point, all you have to do is reverse this process, put everything back where it goes. And this process is going to be pretty much the same with any steam locomotive you're working with. I've done this on brass locomotives. I've done this on UK locomotives. I've done it with American locomotives. And basically, it's all pretty much the same approach. There will be little differences amongst them due to manufacturer differences, but that's about it. Okay, at that point, it's all back together and you're ready to give it a test drive. Well, I tried 3 of these black gears, and they just wouldn't hold on the splines. Every one, I would slide it on there, and it would just strip right off before I even had a chance to give it a road test on the locomotive actually operating. So these are going to be set aside, and now I've switched over, and I'm going to try these white ones because they seem to be very, very fine cut, and they're also very, very strong. So and that's just based on finger test. I can't break them. I'm going to go ahead and I'm putting one on the locomotive and then reinstalling the drive wheel and the driver. And I'll show you in just a second how that works out. Okay, so now I've got the white gear installed on the axle. So let's see how it works. I've got it set up on this rolling road to make it easier. So let's turn it on and watch what happens. Got a nice smooth start there. And I'll run it on up. Okay, that's at about half speed. So it seems to be doing fine. So my next step will be to hook up all the connecting rods and drive rods to the wheels again, and we'll give it a test on the track with an actual back and forth run. Now, one thing I noticed after the test and the fact that this one runs very well, you'll notice there's not that much play in this particular one. There's some side to side, but that's expected. But on the front one here, there's quite a bit of play. On the rear one, it just wobbles all over the place. Let me show you that. So what I think I have to do is, I'm going to pull these out and see if there isn't some way to shim up the bearings in here and tighten them up a bit so that we don't have all that wobble. With the drivers that I want to work on and try to shim out, what I've done is I've cut this little strip of foil. It's aluminum foil. It's heavy duty, so it's a little bit thicker than normal. And I'm just going to press fit it down into this slot. And this is the slot where the bearing sits. So you can see that it's cut in just a little bit. Let me get my tweezers to work this. But at any rate, I'm just going to push it down in here and flatten the little flanges here. And then that's ready. So I can put my knife blade right on there and pull it up and cut it loose. And that way I'm going to have a little bit of a shim down in here, just as thick as some heavy-duty aluminum foil. Let me go ahead and put another one in. Let me take a screwdriver and just set it down in there, like that. Okay, so there it is, in place again. Now let me try to cut it. There it is. I've taken that aluminum foil and created a shim down inside the slot where the bearings fit. Okay, let's drop it in here. Okay, now see how much tighter that is? It doesn't wobble hardly at all. So hopefully that's going to do the job and hold those in place. So now let me put it all back together. So you can see it's taken a lot of that slop out of these. You can see there's nothing in here. There's a tiny bit here. There's still a little bit of wobble here. Nowhere near as much as there was before. Okay, now that I've got these front and rear drivers shimmed up, and this one has a replacement gear that seems to work fairly well, let's go ahead and get the drive rods, the connecting rods, and drive rods all put back together. So first thing you want to do is line up all of your drivers so that the screw hole for the screws that hold this all together are all pointing in the same direction. And that way, when we put these on, the holes should line up perfectly, or pretty close to it. There we go. So what I'm going to do first is stabilize this by going ahead and just installing the screws on these. Okay, that one's started. I want to get them started first, and then I'll go ahead and finish it. Okay, so that one's in. And make sure that you tighten these, because once you start running these, if this is not tightened, if that screw is not in there good and tight, it will back its way out. And I will tell you, it will do it. and it has happened to me. So you need to get it in there good and tight. Don't over tighten it though, because you run the risk of breaking the head off or stripping the threads out. So at that point, I'm just going to take my hemostat and using it like a wrench, tighten the head on this up. You know you're there when it starts to rotate the wheel. Okay, so we'll put that one in, and now I'll turn to tightening this guy here. There. That one seems to be pretty tight. Okay. Now I'm going to run this back down to where it goes, and everybody should line up pretty close. Now, you'll note that there's quite a bit of slop in these, though. Part of that's probably due to wear on the holes over time. And Hornby does sell replacement driver sets. I just don't know if they will actually work with these locomotives since they've changed the gear ratio, or the gears anyway. The others might work, they might not. Only Hornby could tell you that. Okay, let's go ahead and we'll get this guy done. Put that one in place. Okay, I can feel it catching the threads. So I'm going to finger tighten it, and then we will tighten it with my hemostat. So that one's done. I'm going to flip it over and do the same thing on the other side. And to save time, I'm not going to videotape that section. Okay, I've got it all back together, set up here on the track, hooked up to its tender. So let's see how it does. I'd call that a success. There's no wobble, there's no bobble, there's no knocking and popping. It works great, and it's running as smooth as my Blackmore Vale model, which is essentially the same model, but just a few that looks like it's brand new. Whereas this one, it was heavily worn. So I think the combination of the new gear is going to work out, and using the aluminum foil to shim up these bearings and tighten up these drivers really helped a lot. So let me put it all back together. Unfortunately, I can't run it on the DCC layout yet because I have not installed a decoder in it. Now with this section here, unfortunately, the battery in my microphone went dead, and I lost the audio portion of this. So what you're going to see here is just some more run-bys of the locomotive, all completed and put back together. So hopefully this will give you an idea of how well this locomotive is running now. Well, that's a wrap for today's video. This process went a lot easier than I thought. It was fairly simple to pull those drivers off and remove the driver wheels and get the replacement 3D printed version installed on the axle. And I was concerned about that because I was afraid that those splines might cause a bit too much pressure and crack the gear as it was being put on. So right now, it looks like everything is on in place and the locomotive is running again. So hopefully, over the next few weeks, we'll be able to tell whether or not the particular gear that I use is going to hold up under the stress and strain of driving these locomotive wheels. And if it pops, then I will pull it off and put on one of the other ones. And we'll see. We'll find out whether or not any of these are going to last under regular use. So come on back and keep track of whether or not 3D printing gears is going to work for us. And in the meantime, have a great weekend, have a great week, and I'll see you here on Monday with another UK Monday video, and then on Friday with another DCC Guy video. Bye now.